So specific heat is the amount of energy it takes to take 1 gram of that substance and raise it 1 degree. Okay? The 1 gram of that substance and raise it 1 degree.
Specific. What page was that on?
We couldn't find the page.
I have so much junk all over my pages. I can't
So
remember.
that's what specific heat is. So does it take, it's the amount of energy needed to take 1 gram and raise it 1 degree. So if you look at 3 versus 5 on page 5-77, if you look at the slope of 3 versus the slope of 5, okay, which one requires more energy to change 1 gram? 3 requires more energy. The slope is not as steep. Okay, that's where some people get mixed up.
That's
So-
why it's requiring more energy.
The rate of change is slower because, say it, Fatima?
It's taking up, the slope is not that steep. It's taking up only 4 squares.
Mhm.
It's taking up 4 squares in comparison to just 1 square and 5 and 1.
So it requires more energy, therefore it has a higher specific heat. The more energy it takes to change 1 gram, 1 degree Celsius, the higher the specific heat. And what does that say about the slope? The rate of change is slower, so the slope is going to be less steep. So that's where people get it all mixed up. Remember, a steep slope means the rate of change is really fast. That means a low specific heat. It doesn't take much energy. But a more gradual slope means you have to add a lot of energy to change that. And what causes the change? What are you doing to the strength of attraction?
Trying to reduce it.
Okay, so it's so on that x-axis, if you change, think of time as the amount of heat energy added, because it's recording. You've got a hot plate and it's pumping heat into the system. Okay, so let's compare 1 and
Very close.
3.
I did it by,
Did you
it was, they're very close.
It's more, it's more.
1 is a little more steep. If you look, it's like a half
No, it's more.
for
Five
1.
It's like 1/4 of the square, and then
No,
1
I'm
is like.
saying 1 and 3.
1 and 3, comparing 1 and 3.
Yeah.
Look at where 1 is on the x-axis. Try to find an equal one on 3. It's just to the left of the line. Okay, so like this one here, and now we go up 1.
But see, I did it by making triangles. And when you make the triangle down, I did them.
So let's look at that.
You know, when you've got this part,
Okay.
yeah, I got this, right? I made triangles.
And then the angle.
This isn't actual.
The angle is like the same.
Like, this
this-
line.
They're all right triangles, what she made.
Yeah.
Now she's looking
So
at
this line, I
counting
think is
that.
skinnier than this line.
No, but comparing 3 and 1 is like, I think you gotta take this angle right here. And then if these, because if you draw, if you make the 1 the same length as 3, they're parallel. They're like almost the same. They would take up the same time.
I think if you,
This goes more like that.
yes.
I don't think
Yes.
they're not
See
parallel.
that? They're
I think
not
it's
exactly.
more
Not
that-
exact.
Yeah.
Oh, okay. Well, yeah.
I'm pretty sure it'll be pretty clear on these.
When the slope is steeper, it's gonna take less time for that specific, to make the specific, to take it up one degree. Because the slope is steeper, it doesn't take much time.
So the rate
When
of
we
change
compare
is
it to the
faster.
slope that it's less steep, where it's taking more time, like 3, it's gonna take more time for us to make it go, more energy to make it go 1 degree higher. So it has a higher specific heat because
Inverse.
it's taking up more time, and it has has less steeper.
So we're still looking at graphs like 577, but this, I'm just saying, if we said that the rate of change in 1 is 0.1 and the rate of change in 3 is 0.9, the rate of change is 0.1 versus 0.9, which one is going to have the steeper slope or the higher specific heat?
Because it's see, and 1 is a steeper slope.
So it takes 0.9 degrees.
The line that is more steep requires less or has less a specific heat. The line that is more steep requires less heat. Sorry, you have to.
I'm giving you the actual problem, question 5 on the exam, and that's what the ladies were discussing. Do you have anything to add, Carrie?
No, I'm sorry.
Now we're looking at PC8, thermal expansion, and then the second one is contraction, but it just got moved over a little bit. Okay, so that's 2 separate ones. All right. So that's PC8.